All right, so we're going to talk about graphing secant and cosecant. So let me grab a couple of pictures here of these graphs. Oops, what happened there? And I'll grab a cotangent also, or cosecant. All right, so here are two graphs. The key to what we're going to do with secants and cosecants is remembering that this is the same as 1 over cosine x, and this is y equals 1 over sine x. So whenever we have a function that has some other variable quantity, something that changes in the denominator, we have to be careful about when the denominator is 0. And when we're talking about functions and our denominator 0, that gives us vertical asymptotes. So our secant function is going to have vertical asymptotes when cosine x equals 0. So here I have asymptote at negative pi over 2 and pi over 2, 3 pi over 2, everywhere where cosine is 0. Similarly for cosecant, we're going to get vertical asymptotes when sine x equals 0. So we get vertical asymptote at 0, at pi, at 2 pi, etc. But we already know how to sketch the graphs of sines and cosines, and it's easy to figure out where they equal 0. It's where they cross the x-axis. So that's our key to sketching these things, is we're going to actually sketch in the graph of secant or sine, and if we sketch that in, it would go like so. Like that. Same thing here. And we get our vertical asymptotes everywhere this graph of our original function crosses the x-axis. So the red part is actually the graphs of our cofunctions, and the blue part that I sketched in there is a graph of the original function. So that's what we're going to do to graph these things. We're going to sketch a graph of the parent function. And then we just sketch then we put in sketch the graph of our cofunctions between the asymptotes. Oh, let me add one more step here. We can call it 1.5. We get vertical asymptotes where the parent function equals 0. Everywhere it crosses the x-axis. Graph the cofunction between the asymptotes. And our cofunction goes right on the top of the maximum are right on the bottom of the minimum, because when sine of x is 1, the cosecant of x is also 1, because we just get 1 over 1. So we put it on the top or on the bottom of our function there, and sketch our graph between our asymptotes. And we don't have to, I'm not worried about plotting additional points in here. So it's roughly a parabola shape, sort of. More of a U shape than a parabola, but it's close to a parabola. So we already know how to graph our parent functions, so that's why I said we already know 95% at least of what we need to do to graph these things. So all I want to do is go through a couple of examples of graphing a secant and a cosecant so we see the process, and then we'll be done for today. All right, so questions on the idea here? Okay. So we're sketching a graph of these things. Y equals 2 cosecant x over 2. So our parent function is y equals 2 sine of x over 2. So we have a is 2, b is 1/2, so our period is 4 pi. We get key points every pi units. We're not shifting anything, so this one's pretty quick and easy to sketch. So label my axes. And our amplitude is 2. And my parent is a sine function. So I'm going to start here at 0, 0, and then sketch in my key points every quarter period. There we go. I'm going to sketch in my asymptotes everywhere the parent function crosses the x-axis. We get one there. And then I'm just going to put my function between the asymptotes. Uh-huh.
So for the co-functions, we just kind of like guesstimate where it.
Yeah. I'm not worried about the plotting points there. So we just kind of make a U shape in between the asymptotes. Yeah.
How do you know which one, like which side to put it on?
It goes up from the top or down from the bottom. So it's always either at a maximum or a minimum, where it's a +1 or -1. If it's down here, it goes down. If it's up here, it goes up. Because since it's a reciprocal, if it's positive, it stays positive. If it's negative, it stays negative. Yeah.
On a test or quiz, you want us to leave in the parent function?
That's fine. Some students like to erase it. It doesn't matter to me. Yeah.
How do we switch from the co-function to the parent? Like, what's the...
Well, we know that the cosecant is 1 over sine.
Yeah.
So for cosecant, the parent function is always sine. For secant, the parent function is always cosine.
So you just split them out?
You just swap them, yeah. All right. Questions there? So the graph of the cofunction is just the blue parts, the U shapes. We sketch in the graph of the parent function because that's what gets us the details we need to graph the other function. All right, let's look at one more example. Let's do a secant graph. we'll graph y equals secant x plus pi. So a is 1, b is 1, period is 2 pi. We get key points every pi over 2 units, quarter of the period. And we're shifting left pi. So we're ready to sketch. I'm going to label my axes in terms of in units of pi over 2 for my key points. And I'll go in the negative direction. And we're graphing a secant, a cosine function. Oh, my parent is, got to write that. No, no, not this time. So that's my parent function. So it's a cosine function, so I'm going to start here at 1 and then graph my key points here. And I'll get a couple more here. My asymptotes everywhere the parent function crosses the x-axis. And then sketch in my function. And there we would have a couple of periods of that secant function. Yeah.
So the cosine function, why is it upside down? Because there's no negative?
No, because we shifted it over pi, so we started here.
Oh, okay.
So it shifting by pi makes it look like a reflection. All right, questions? Okay.
I have named what price is saying, and I would like to find out.
What's that? I will give that suggestion, Caleb. I will give that suggestion all the consideration that it is due.
Thank you. So many numbers.
Yes.